So one thing that we need to talk about first is that so when we talk about writing down quantifiers, we have to put this domain. Right? When you say like for all x in some domain, blah blah blah. And so in Disco, what we've been calling a domain is called a type. That's another very common word for this kind of idea. A type is basically a collection, some collection of certain types of values. Okay? So in Disco, there's a bunch, but I'm just going to talk about a few today, and we'll talk about more as we get to them. So one that we've kind of already seen, even though I didn't mention it at the time, is called bool. So if I can ask for the type of something by saying :type. So if I ask for the type of false, it says bool. So bool, that's an abbreviation for Boolean, which is named for this English mathematician named George Boole, who he didn't come up with the idea of logic, but he came up with the idea of like using algebraic kinds of techniques to do logic. So before that, everyone was just talking in sentences and thinking about, does this make sense or not? And he's like, no, but we can actually write down things in terms of like, you use symbols for and or, and talks about what are some laws for how you can manipulate these things, just like we've been talking about. So true and false. So bool is the domain of just true and false. Okay. The other thing we can talk about, the other domain is this is the domain of integers. Disco prints it out using this like cool /z, which maybe you've seen this notation before. It doesn't matter if you've seen it before. We're going to use it much more in a week or so. But you can also write. You can notice that here I put :integer, and it was okay with that. It's like, oh yeah, you mean z. So I'll write it out as integer for now, but Disco usually prints it out using the Okay, but this is just like all the whole numbers, including positive, negative, 0. Okay. So how can we write quantifiers in Disco? So let's do something simple like let's say for all. Right? I could also write it using the upside down A if you know how to type that in your keyboard. I don't, but you can also just write out the word for all. So for all n integer, let's try Boolean first actually. So for all p is a Boolean, I don't know, like p implies p. Okay. So if I just hit enter here, it's just going to tell me, this basically means, yeah, that's a proposition, but it's not willing to, it's because, well, I'll just show you. So what we actually have to do, if we wanted to like test this for us and tell us whether it thinks this is a true or false proposition, we can say :test, and then we put whatever proposition we want. Okay. So it says the test passed, meaning it thinks it's true. And in this case, it says no counterexamples exist, which means basically I tried all the possibilities. It basically went through a whole truth table, and it's like it worked for everything, so therefore it is definitely true. Right? We could try something else like, I could say p or not p. Right? That works too. But if I try something like what if I just said for all p, p? It's like p is always true, no matter what p is. That's ridiculous, right? So it says, oh, that's false. Here's a counterexample. When p is false, this doesn't work. Right? Or we could try, let's do something slightly more interesting than that. So like, let's introduce q. P and q implies p or q. Right? Maybe this is not quite as obvious to us whether this is going to be true or false. Okay, so that is true actually. Right? And again, since there's only only 4 possibilities. It went through all the possibilities and tried them all, and it says, nope, this is always true. If I switch these though, let's say if P or Q implies P and Q, it says, nope, that's false. Here's a counterexample. When P is false and Q is true, that doesn't work. Okay? So, when our domain is stuff involving Booleans, right, because there's only 2 possibilities, Disco can actually try, it basically makes a giant truth table, it tries everything, and it can tell us for sure whether that proposition is true or false. Okay? But let's try some things with integers. This is where it gets a little more interesting, because we can certainly write down a proposition about, for all integers or something. But Disco can't actually try all integers. Okay, so we'll see what it does. So if I say test, let's say for all natural, or for all integers n, n squared is greater than or equal to 0. So this is how you write an exponent, use a little caret symbol. So we believe this is true, right? Disco is not smart enough to prove it, basically. But what it can do, and it's also not going to go and try every integer because that's impossible. What it can do is try a bunch of random integers and see if it works for those or not. Okay? So it says, your test passed because I checked 100 possibilities and it worked for all of them. Okay? So this doesn't tell us for sure that it's true. It's maybe some evidence that it might be true. Right? And if I try something, let's say, n is less than 0 or n is greater than 0. This was another one that we did, right? And this one is false, right? And again, it's going to try a bunch of random numbers and see if it works. And it says, no, it's false. I found a counterexample. When n is 0, that doesn't work. Okay, so it actually found the counterexample in that case. But we can try to trick it on purpose. I can say for all n, n is not equal to, this is how you write, I don't think, I forget what this is. N is not equal to 784. That's the wrong. It says, yeah, it passed. I tried 100 random integers, and that was true for all of them, so might be true, right? Obviously, to us, it's obvious that's not true because we know that you can specifically pick 784, and that makes that false. But Disco didn't find it. It was trying random things, right? We could also say things like, this is one we did before. One tricky thing here. So, in many ways, I've tried to make the syntax of Disco as close to the syntax that we use in math. Okay, so that, when you write and, you write it looks like an and symbol. The way we write for all is exactly the same as the way I wrote it before. Okay, this is one place where that's not really possible. And there's good reasons for that. But when mathematicians use equals, there's 2 different things they could mean, and it's not obvious that they're using it 2 different ways. One way is to define something, say, oh, x equals 5, let x equals 5. Another way is to basically ask, are these 2 things equal? Or just to state the proposition that these 2 things are equal. And those are different. And so Disco actually, and it would just, if we did this, it would give an error, right? Because I'm not defining n plus m to be 5. I'm asking, are they equal or not? Okay, so if I try to do this, I'm going to get an error. Or it says, oh, I didn't expect an equals there. That doesn't make any sense. Okay, so I have to put a double equals. That's how in Disco you ask, are these 2 things the same or not? Okay, and interesting. What does that mean? Oh, it says, I don't think it's true because when n is negative 21, I didn't happen to randomly find an m that makes this true. Okay, so again, it's not super smart. You can definitely imagine ways to make it smarter, but right now it's just trying random things and tell you if it's definitely true or false in some cases, or it can say, well, I tried a bunch of things and maybe it is real. So, for example, if there's a proposition you're like, I'm not sure if this is true or not, I can just put it in here, and if it says, no, it's false, here's a counterexample. Well, great. Now you know for sure it's false. Right? But if it's like, oh, I checked a bunch of things, then you're like, okay, well, maybe it's worth investing more effort into trying to, like, figure out why this is always true.